All right, we are doing indicator 3, day 1. So on your notes, indicator 3, day 1. And we should sound pretty familiar. If you can read my writing, it kind of gets terrible because my hand has to hover. Solving for a variable. Solving for a variable, okay? And this should sound pretty familiar because we are used to solving for a variable. That's what our jump start was today, right? We solved for x. So we did some addition, subtraction, a little bit of multiplication, and we got x by itself on one side of the equation. So that's what solve means, right? This should be a review from indicator 1, day 1, right? To solve means to get the variable alone on one side of the equation or of the equal sign. Okay, that's what it means to solve. And we talked about that when we did indicator 1, that our goal is always to get the variable alone. And we do that by always add and subtract those easy break-off ones first, and then do whatever multiplication, division you need to do, and then any last-minute steps to get the variable by itself, like our jump start today. And usually, and what we're so used to, and especially when you're thinking mathematically, your goal is to get like our jump start, right? X equals 30, or in inequalities, x is less than 2. And it's a nice, neat answer. And if you plug it back in, you get, you can check to see that it's the right answer. And it's just a nice, neatly wrapped, perfect answer. Well, for indicator 3, I call this my ugly indicator because you get ugly answers and you don't get answers that make sense kind of in your math brain. And so we'll do several examples and you'll see what I mean. But just know that solving in indicator 3 just means get the variable by itself. Okay, no matter what weird, chunky, ugly thing is left as your answer, as long as your variable is by itself, you've solved it, and that's the goal. Okay, so I know it's kind of a weird setup, but let's do a couple of examples and you'll see what I mean. All right, so example number 1 is 2x minus 3y equals 6, and our directions are to solve for y. And I will tell you for day 1, for the day 1 notes and your day 1 homework, everything's going to be solved for y. When you get to day 2, it'll say solve for m, solve for f, solve for g, solve for x. Everyone will be different, and you have to really watch each problem. But for day 1, we're going to always solve for y. So on all of our examples today, we're going to always be solving for y. So solve for y, we know that what solve means. We know that that means to, right, do whatever we need to do to get y by itself. And the way I've always said it to you guys is what's attached and how is it attached, right? And we always do the opposite to break it loose. So if you look at the left side of the equation, with that y, we have a 2x, which is attached by addition, subtraction, and we have a 3 that's attached by multiplication. So using the order that we know to use from our indicator 1 notes, which one of these are we going to break off first? Yeah, the 2x, because it's attached with addition, subtraction. It's the one furthest away from the y. It's the easiest one to kind of snap off or to break loose. So it's currently a positive 2x, so I'm going to go minus 2x. And over here, I'm going to do minus 2x. And when I do that, my 2x minus my 2x goes to 0. And you don't have to write 0 unless you need a placeholder, which here we don't, because we still have negative 3y over here, right? And then on the right side of the equation, we have a 6 and a negative 2x. Well, these are not like terms. We can't combine these. And the knee-jerk reaction that I always get is for people to write 4x. Right? Because 6 minus 2 is 4. You can't do that. The 6 is a whole number. The 2x has an x with it. Those are not like terms. Bless you. Those are not like terms, so you can't combine them. So you just have to write them separate. So you keep them separate. So 6 minus 2x. Can't combine them, leave them separate just like that. Now we still need to break loose the -3 from the y, and it is attached with multiplication. So we're going to break it loose with division. So I'm going to divide by -3, and I'm going to divide this whole side by -3. And when I do that, the -3 and the -3 cancel each other out, and I'm left with y over here, which is what we wanted. And on this side, I have this big chunky 6 minus 2x divided by -3. That is not a normal answer that we are used to getting in math. However, is your y by itself? Have I solved for y? Yep, that's your answer. Do what? It is. As long as you stick to what are you trying to get by itself, and then just look at what's attached and how it's attached. As long as you will do that and always break loose the addition, subtraction first, then divide whatever you need to divide off, whatever chunky answer you get, it's okay to leave it like that. Yes. That's okay. So for me, for my homework, I am fine if you leave it just like that. Okay? But you can actually simplify this a little bit. And the reason I want to address this is because on Wednesday, you're going to be doing a Khan Academy assignment that's solving for different variables. You can actually reduce this a little bit, and it has to do with the distributive property. So we know from doing all of our equations the last couple weeks, if we have a number right outside of a parentheses, that's multiplication, and you have to distribute that multiplication to everything inside, right? Well, the division problem is the same way. We have to distribute that -3 to everything on top. So really, you could write this as 6 over -3 and minus 2x over -3. And then you could reduce again. And what is 6 divided by -3? -2. And we know that a negative and a negative goes positive, so -2x and -3 would actually go positive. Whoops. I'm just going to rewrite that whole thing. That's not very pretty. All right, so we got -2, and then a negative and a negative goes positive, and 2/3 x is left when you reduce. Now, this right here and this equal the same thing. But I just want you to be aware that if you do our Khan Academy and you reduce it on your scratch paper, and then you look at your 4 possible answers and none of them look like what you have, try to reduce it a little bit. Put that fraction, that -3, put it under everything on top, and then reduce each thing individually. And you might find that the reduced version is what Khan Academy actually uses for one of your answers. Now, for me and my homework, I'm fine if you just leave it like that first box, okay? And you don't need to worry about reducing it. All right? But I just want you to be aware that you may have to reduce it for Khan Academy. The only time I would want you to reduce it is if both things on top are divisible by 3. That might be an easy reduction. But if everything isn't going to come out perfect, just leave it kind of big, okay? Good question. Any other questions? All right. Let's do another example. So example number 2 is C equals 1/3 xy. Again, our instructions for all of day 1 is solve for y. So I want to get y by itself. So I need to look and see, right? If it helps to put a square around it, that's what I'm trying to get alone. You need to look at what's attached and how is it attached. Well, we have 2 things attached to our y. We have a 1/3 and we have an x, and they're all attached by multiplication. But the 1/3 is a fraction. How do we get rid of fractions? Multiply by the denominator. So if I multiply this whole side by 3, and I multiply this whole side by 3, because I have to do equal to both sides, 3 times c is just 3c. And our 1/3 is canceled out by our 3, so we're just left with xy. We still need to get y by itself. It's currently attached to that x with multiplication, so we're going to get it off of there by division. And since it's the x I want to break loose, I'm going to divide both sides by x. These x's cancel out. And on the left, right, you're left with 3c over x. That is a very weird answer in math, but that is actually your answer. Your y is solved. Your y is by itself. Leave that kind of that chunky, ugly mess over there. Just leave it just like it is, okay? Now, the only way you might clean it up, or you might see it cleaned up on Khan Academy, is if Khan Academy really wants that y over there, it might be written like this, but it's the exact same thing, right? I didn't change any signs. I didn't change any values. I just wrote them on opposite sides of the equation, okay? And again, for me, my homework, I'm totally fine with that. You can leave it backwards. Okay? Any question on that one? So if you have a fraction, multiply that by that denominator to get that fraction off of there. You do, like your very first one on your homework is like that. All right. This one's pretty straightforward. If we have 14z plus y equals 6x. And again, all of day one, we're solving for y. So that means our goal is to get y by itself. What's attached and how is it attached? Well, that 14z is attached, and it's attached with addition. So I'm going to subtract 14z and subtract 14z. And when I do that, positive 14z and negative 14z go to 0, leaving me my y. And my 6x and my 14z, those are not like terms, so I can't combine them. So I'm just going to keep them separate and write them just like that. And again, y is by itself, you're solved. And this is just my own little personal thing I do to help not combine the wrong things. Is you'll notice my 14z and my negative 14z, I put those right up underneath each other, right? Because that's what I'm using to cancel out. When I wrote it over on the right, I wrote that negative 14z out just a little bit, just to remind myself that when I'm writing out my right side of the equation, those two can't be combined. I just need to write them out in a long line. So 6x minus 14z, okay? Any question on that one? All right. Y plus 20 minus 10x equals negative 15. Okay, again, I look for my y. There it is. That's what I want to get by itself. I've got a plus 20 and a negative 10x, both attached with addition and subtraction, so it doesn't matter which one you move first. So I'm going to move that 20. It's a positive 20, so I'm going to go minus 20. Now, notice on my right side, negative 15 is a whole number, and I'm moving negative 20 over, and that's also a whole number. So I'm going to write it right underneath it because I'm going to combine those two, right? They're both whole numbers. So my plus 20 and my minus 20 over here go away, and I'm left with y minus 10x equals, I haven't done anything with that 10x yet, negative 15, even further negative 20 goes negative 35. Now I need to subtract off or add that 10x, right? So it's currently attached with a plus minus, so I'm going to break it loose with plus minus. It's negative 10x, so I'm going to go positive 10x. And over here, I'm going to do positive 10x. And again, notice I kind of write it off to the side a little bit because I can't combine it with that 35. It's 35 and 10x. They're not like terms. So the negative 10x and the positive 10x cancel, leaving me with y. And then on this side, it does not matter which one you write first. So I can either write my negative 35 first and my positive 10x, or I can write my positive 10x first and my negative 35. Doesn't matter to me which way you write it. Okay, both of these are perfectly good answers. Just know that if you write it like this when you're doing the Khan Academy work, and this is not an exact match to one of your 4 choices on Khan Academy, just think about, can that be written in a different order? Because Khan Academy might write it like that. Okay? Any question on that one? All right, I got one more example, and I specifically picked this example because this tends to trip people up the most because there's absolutely no numbers. And there's one like this, just like this on your homework. So m equals yn plus z. Okay, extremely strange looking for a math problem, but we still work it with the same mindset. Our goal is to get y by itself. So we have to ask ourselves, we have the n and the z. The n is attached by multiplication because anytime two variables are touching, it's multiplication. And that plus z is a plus minus. And we always break off the plus minus first. So I'm going to subtract z. And over here, I'm going to subtract z. And again, I'm going to write it off to the side because I have an m over there on the left. I can't combine it. So on my left, I have, and it doesn't matter what order you write it, I have m minus z equals yn, right? My z's over here canceled out. And you could have written negative z plus m. That's perfectly valid as well. But now you need to get that n off of there because your goal is to get y by itself. It's attached by multiplication, so that means you divide by n and you divide this whole side by n. Your n's cancel, and you're left with y. And then over here, right, as weird as it looks, this is your correct answer, and that's how you would leave it. So you still do the same kind of mathematical mindset as far as add and subtract. If it's attached by multiplication, you do division, but it's just with letters instead of numbers, so it kind of throws people. Any questions on these? All right, if you're watching this virtually, make sure you're taking all the notes, showing all the examples in your 3-ring binder, and then click on the home page and the load button and work it through Kami. And when you're supposed to show all your work, this is what I mean. Showing all the work, all the plus, all the minus, all the division, multiplication, all the steps needed to get to your answer, and then circle your answer. And when you're done, submit it. And then I'm going to end this recording, and then I'll talk to the in-class students.